in this video, let's learn how we can design the circuit for D latch, or known as data latch or transparent latch. And also let's learn how we can derive the truth table for it. So in the previous videos, we learned about the set reset latch using NOR gates or using NAND gates, and then we derived also the state table or the truth table for it. Now let's take this set reset latch and modify it to obtain the circuit for the D latch. So let's take this SR latch. We have the set input and the reset, and we have two outputs, Q state and Q bar or Q prime. So now to design the circuit for the D latch, we can add two AND gates, one for the set and then one will output the reset. We can use gate and tie it to both inputs of the two NAND gates. This is our G, and then we can use another input, the D, and then we can use an inverter here or NOT gate, and then this will be the other input for the bottom AND gate. So now this whole circuit will be the D latch. It has two inputs, D and G, and two outputs, Q and Q bar. Now let's derive the state table or truth table. So we have two inputs, gate or enable, D, and then let's also list the current state of the circuit or the system, and then we want to figure out the next state known as Q plus. So how many combinations of G and D we have? So we start with 0, 0, but the current state could be 0 and could be 1. So that's why we write it twice. Same thing for 0, 1. Q could be 0, could be 1. 1, 0, we write it twice. Could be 1. Let's stay consistent, 0, 1. And then we have 1, 1, we write it twice, because Q could be 0, could be 1. Now let's figure out the next state. So for the first four rows, the gate is disabled, G is 0. So let's put 0 here in our circuit. First row, we have the D is 0 and Q is 0. So D is 0. And then at the bottom here, we have an inverter, so the output will be 1. Because D is 0, will come here, and then we will output 1. It will invert the 0. So now for the top AND gate, 0 and 0, the output will be 0. The bottom AND gate, we have 0 and 1, so the output will be 0 as well. Because the AND gate will output 1 only if both inputs are 1. So now let's look at the state table of the SR latch. So when S is 0 and R is 0, no change, so we hold the previous state. In all of these four rows, since the gate is disabled, so one of the inputs of the AND gates is always 0. So no matter what is G and D, no matter what D and Q are, we will always output 0 here for the first four rows. So in these four rows, we will hold the previous state of the system. So Q plus will be equal to Q. So this row, Q plus will be 0, 1, 0, 1. Because in these, we hold the previous state. Now let's see when the gate is enabled. So let's analyze the circuit for the bottom four rows. So let's delete. And then now we have the gate is enabled. So let's start with the first row. D is 0. So we have 0 here. At the bottom, we will have 1. So the top AND gate will output 0. The bottom AND gate will output 1 because both of them are 1. When S is 0 and R is 1, so we're looking in this row here. The next state will be 0. We set the next state to 0. Now let's look at this row. D is 0. So the output will be 0 as well. The next state will be 0. Now let's look at this row here. Now D is 1 instead of 0. So we'll have 1 at the top, 0 at the bottom, because it will invert the 1 to 0. So the top AND gate, we will have 1, because 1 and 1, the output will be 1. The bottom AND gate, the output will be 0. So what happened when the S is 1 and R is 0? Looking here, we are setting the next state to 1. So at the bottom here, both will be 1. So let's look closely at the when the gate is enabled. So Q plus will be equal to D. That's why we call it the transparent latch as well. So this is that. Now we can use the K map to obtain the function or the Boolean function of the Q plus, the next state. So we can use the G, D, and the Q. So we have three variables K map. We can construct it this way. We have a G, DQ here, or we can construct it this way. We have a GD here, and a Q is here. So let's follow this path. So G could be 0, could be 1, and then for DQ we have 0, 0, 0, 1, 1, 1, and 1, 0. So let's fill the table. So in this cell here we have 0, 0, 0. So Q plus is 0. Next, 0, 0, 1. So 0, 0, 1, we have 1. Next, 0, 1, 1. So that's 0, 1, 1. We have 1. Next, 0, 1, 0. So that's 0, 1, 0. We have 0. Same thing for the bottom 4 cells. So first we have 1, 0, 0. Looking up here, we have 0. 1, 0, 1, we have 0. 1, 1, 1, we have 1. And 1, 1, 0, we have 1. Now let's group. We can group these two together in one group, and we can group these two together in one group. So the yellow will give us, so since G is 0, we have G prime or G bar. And then also we look here, Q is not changing and it's 1. So that's Q. And then for the green, we will get G. And then we have D is not changing and it's 1. So that's GD. So now we can write the equation of Q plus equal G prime Q plus GD. So that's it on a D latch. I hope this was helpful. Thanks for watching.